One of the most frustrating parts of general chemistry is feeling like you have to memorize a giant list of polyatomic ions. Nitrate, nitrite, sulfate, sulfite, carbonate, phosphate, chromate, dichromate, permanganate, hydroxide, acetate. And for many students, it just feels like one long list of random names and formulas. But here is the good news. You actually do not need to memorize every single polyatomic ion independently. Instead, we can group many of them into families. If you memorize one member of the family, the naming patterns allow you to figure out the others. That means instead of memorizing 20 or 30 completely separate ions, you are really memorizing a much smaller number of families. Let's start with one of the biggest families, the nitrogen oxyanions. If you memorize nitrate, you can build the rest of the family. Nitrate is NO3-. This is our reference ion. Now let's apply the naming rules. If we remove one oxygen, the ending changes from ate to ite. That gives us nitrite. NO2-. If we remove another oxygen, we add the prefix hypo. Hypo means one fewer oxygen than the ite ion. That gives us hyponitrite. NO-. If we instead add one oxygen to nitrate, we use the prefix per. Per means one more oxygen than the ate ion. That gives us pernitrate. NO4-. Notice something important. Throughout this entire family, the charge never changes. Only the number of oxygen atoms changes. So instead of memorizing 4 completely different ions, all you really need to memorize is nitrate. Once you know nitrate is NO3-, the naming rules let you build the other members of the family. Now let's use the exact same idea for sulfur. If you memorize sulfate, the rest of the sulfur family becomes much easier. Sulfate is SO42-. Remove one oxygen, the ending changes to sulfite. SO32-. Remove another oxygen. Hypo means one fewer oxygen than the ite ion. Hyposulfite would be SO22-. Add one oxygen to sulfate. Persulfate would become SO52-. Notice that we never changed the charge. We only counted oxygen atoms. The exact same pattern works for phosphate, chlorate, bromate, and iodate. Once you understand one family, you already know how to build many others. There is one more family pattern that students often overlook. Sometimes a hydrogen ion, H+, combines with a polyatomic ion. For example, if we combine H+ with sulfate, SO42-, we get HSO4-. This ion is called hydrogen sulfate, also known as bisulfate. Notice what happened. We did not create a completely new ion. We simply added one H+ to sulfate. Since H+ has a positive 1 charge, the overall charge changes from 2- to 1-. The exact same idea works for carbonate. If we combine H+ with carbonate, we get HCO3-. This ion is called hydrogen carbonate, also known as bicarbonate. Again, we simply added one H+. The overall charge changes from 2- to 1-. Once you recognize this pattern, hydrogen sulfate, bisulfate, hydrogen carbonate, and bicarbonate become much easier to remember because they are all built directly from the parent polyatomic ion. Now there are a few exceptions. Chromate and dichromate are related, but instead of changing oxygen by 1 each time, the prefix di tells us there are 2 chromium atoms. Chromate is CrO4 dichromate is Cr2O7 2-. These are best memorized together as their own family. Permanganate is another common ion that is usually memorized by itself because it does not fit the same naming pattern as the other oxyan ions you learn in general chemistry. There are also a few important polyatomic ions that do not belong to large families. Hydroxide, ammonium, carbonate, acetate, cyanide. These are simply worth memorizing individually because you will use them all throughout chemistry. So what should you actually memorize? Memorize the parent ion for each family. For example, nitrate, sulfate, phosphate, chlorate. Then memorize the naming rules. Ate is your reference ion. Ite has one fewer oxygen. Hypo has one fewer oxygen than ite. Per has one more oxygen than ate. If that parent ion also has a hydrogen added to it, simply combine H+ with the parent ion. For example, sulfate becomes HSO4-, hydrogen sulfate, or bisulfate. Carbonate becomes HCO3-, hydrogen carbonate or bicarbonate. The positive 1 charge from hydrogen increases the overall charge of the ion by 1. Once you know the parent ion, you can build the rest of the family without memorizing each one separately. Instead of one giant list of unrelated formulas, you'll start seeing groups of connected ions. And that makes naming compounds, writing formulas, predicting products, and balancing reactions much easier throughout general chemistry.